Hello, in today's session we are going to discuss the Spear correlations or the Rank's correlation coefficient, and also we are going to calculate the rank correlation in our second example. So to start with, we know that the correlation coefficient shows the relationship between two variables, So for us, we need to give the formula which we can calculate to get the rank, the Spear, the coefficient. So in this, we normally say that our correlation coefficient, which is given as R is equals to n, where is the number of observation, multiplied by the summation of x y minus the summation of x multiplied by the summation of y, and all this we are supposed to divide it by the square root of n, summation of x squared minus summation of x squared multiplied by all these. We are supposed now to multiply it with the summation of n, summation of y squared, so this is no summation here, summation of y squared. Then we subtract also the summation of y squared, the summation of y squared. So for us, from the data that we are given here, we know that the following data shows the advertisement cost of the corresponding sales revenue for MA enterprise for a period of 9 months. So the first question is calculate the Spear's correlation coefficient. The Spear's has a wrong spelling, and interpret the result. So the first column that we need to get the column of x, the column of xy, whereby we are going to multiply the x and y. So we can multiply 1 times 9, we get 9. 1 times 9, sorry, we get 9 here. And then 2 times 6, we get a 16. We get a 16 here. And then 3 times 10, this one should give us a 30. This one is a 30. And then we have 4 times 12, which is equals to 48, and then we have 11 and 5, which should give us a 55 here. And then we have 6 and 13, which should give us a 78 there. And then 7 and 14, which should give us a 98 here. And then 8 and 16, which should give us a 128 there. And then we have 9 and 15, which should give us a 135. So the next thing that we need to get a column of x squared here, and if you square 1, you get a 1, and if you square a 2, you get a 4 here, and if you square 3, you get 9, there, and if you score 4, you get a 16 here. So in this case here we have a 16, and then if you square 5, you get a 25. So here we have a 25, and if you score 6, you get a 36 here. And if you square 7, you get a 49. You get a 49 here. And if we try to square 8, we get a 64. There. And if we square 9, this one should give us 81. And if we come to the next column that you're supposed to get, we are supposed to get the column of the y squared here. And for us to get the square of y squared, we know that 9 multiplied by 9 gives us 81, and also we have 8 multiplied by 8, which gives us a 64, and then we have 10 squared, which is equals to 100, and then we have 12 squared, 144, and then 11 squared, which gives us a 121, and then we have 13, which gives us a 169, and then we have 14, which gives us a 196, and then we have a 16, which gives us 256, and then we have a 15, which gives us 255. So from here now we can be able to get their totals. We know that the summation of x in this scenario, that is this column here, should give us, if you add this, should give us a 45 here. And then we know that if we add the y, this one is giving us a 108 here. And if you add this, should give us something to do with 597. And if you add x squared column, this one should give us 285. And then if you add the other column, should give us a 1356. So we can come and plug them to our formula now. We can come and plug them to our formula so that we can get our hull is equals to the total observation that was made, that is our n, is equivalent to 9. So we have 9, our n is equals to 9, and then total of xy, this one should be multiplied by 597 from the graph, and then 596 we minus the summation of x is 45, and this 45 we also multiply it by 108, and then we divide our total by 9 multiplied by x squared total, which is equals to 285, then minus the summation of x squared is 45 squared, then this one we multiply by n, which is n, which is so this we multiply by 9 multiplied by 1356, we have 1356, then this one we minus 108 squared. So if we added all these, we are supposed to get our hull being is equals to 553.73. then this one minus 4880, we subtract, we divide 8 by 540, and this one we multiply it by 540 also here, coincidence, and this one should give us our hull is equals to 513 divided by, remember this one is square root, divided by the 540 so that it gives our hull is equivalent to 0.95. And in part B we are told to interpret the result, so we can interpret it and say that we had highly positive correlation in that scenario. Then let us go to the second part, which will be solving the difference. So in this question we are given that a group of 8 accountancy students are tested on a quantitative analysis in law, and then calculate the Spearman's Rank Correlation coefficient. The Spearman's, this one should be the Spearman's correlations, and then interpret the result. So in this case, we know that the rank correlation, this one was given by somebody known as the Charles Edward Spearman in 1902, who was a great psychologist, and he came up with a formula that we can work out to get the rank according to the qualitative. Maybe in case we are measuring something like the leadership qualities, we need to measure it by rank. So, and in this case, he came up with the formula which we have. Our rank can be given by 1 minus 6, then we have the summation of our d squared divided by n cubed divided by n cubed minus n cubed minus 1. And this one can also we can factor out the n out, so we have our r being is equals to 1, then we subtract the summation 6 summation of our d squared divided this is up to here, divided by, we factor out n outside, and then we are left with n squared minus 1. So the first thing that we need to do here, it is to rank this our result. We rank this our result. So from here, the highest was d, which was 1. This one becomes our R1, and then the second one was we had 2 here. Then the second one, I think this one is number 7. This one is also number 6. Then we also have this one being number 4, and also we have this one being number 3, number 5, and then number 5, and then we also have this one. So this one is supposed to be number what? We are missed. This one is 8. This one is 8, and then the other one is number 7 here. We have that one being number 7 there, and then also this one is equivalent to number 7 here, number 7. Then we have number 8 there. Maybe we have number 1 here. We also have number 5 there, and also we have number 2 here, and here we have number 4. Here we have number 6, and here we have number 3. So this one is our rank 2. So now the first column that we need to get, we need column this, which is our d, which is the difference, and to get d is rank 1 subtracted from the rank 2. So our first d, we are going to have 2 minus 3, which is -1, and then 7 minus 6, which is also -1, and then we have 6 minus 4, which is equals to 2, and then we have 1 minus 2, which is going to give us a -1, and then we have 4 minus 5, which is equals to giving us -1 also, and then we have 3 minus 1, which should give us a 2, and then and then we have 5 and the 8, which should give us a -3, and then we have 7, and that should give us a 0. So the next column now, to do away with our negative, we square the d, or the difference squared here. So that 1 squared becomes 1, -1 becomes 1, 2 becomes 4, and then we have -1, which becomes -1, which is equals 1, and then we have 4, and then we have 9, and then we have 0. So So now the next thing, we need to get this total here, which is a summation of d squared, which is equals to, we just add 1 plus 1, which is a 2, 2 plus 4, which is a 6, plus 1, which is a 7, plus 1, 8, then plus 4, which should give us a 12, then plus 9, which should give us a 21, which should give us a 21. So for us to calculate the rank correlation, which is also known as the Spearman rank correlation, we need to use this formula. And now with all this, we know that our number of observation here, n, is equals to 8, so we can come and plug them to our formula. So in this case, now we are going to have our rank, our R, is equals to 1, then minus 6, this one multiplied by our d squared is equals to 21, our d squared is equals to 21, then this one we divide here by our n, which is equals to 8, then we know that our n squared here is equals to 64, then we can minus 1, we minus 1. So in this case, when we solve out this one, let me take my calculator so that I can be able to calculate for you the values. But we know that if you multiply, we multiply 21 and 6, so here we are going to have our R is equals to 1, then minus, we multiply 6 multiplied by 21, and in this case we get this one as 126. We get it as 126 divided by 8 times 64 minus 1 becomes 504. So now if you divide that, our R will be equivalent to 1, then minus 0.262, and if you subtract the 2, you get our R being 0.734. And you can see in the second part we are told to interpret the result. So we can interpret the result and say that there was a highly positive correlation between the performance of quantitative analysis and the law. And that brings us to the end of our session. I was your trainer, Maurice Monene. If you have found it of benefit to you, consider subscribing, like, and share it to reach more so that they can benefit from the knowledge also. Thank you.